Hello, friends. I hope you all are doing good. So, in this data science lecture, we'll study our last unit, which is association rules. So, in this video, we'll cover how to mine association rule using Python, how to apply the confidence difference criteria using Python, and how to apply the confidence quotient criteria using Python. So, let's begin without any further delay. So, first, association rules. We'll see introduction to association rules. Imagine a rule like this: if a customer buys bread, they also buys butter. This is an association rule. We use it to find patterns in data, like which products are often bought together in shopping carts. So basically, if you are doing this, you will also be doing that. It's just like that. For example, if people who buy diapers also often buy beer. This insight can help stores arrange items or plan proportions. Now we see some important terms related to this. First is support, the percentage that shows how often both items like bread and butter are bought together across all the transactions. For example, if bread and butter are bought together in 10 out of 100 transactions, the support is 10%. Then comes confidence. Confidence measures how often the second term, like butter, is bought when the first item, like bread, is bought. If this happens in 8 out of 10 cases, then the confidence is 80%. So basically, confidence is applied on the second item and the support is applied on both the items. And then come the lifts, tells us how much better our confidence is compared to a random chance. So basically, it compares the confidence and how it is better and by what margin it is better than a random chance. For example, if lift is 2, it means the value of the lift is 2. It means the chance of the buying butter when bread is bought is twice high as buying butter randomly. So it means the chances of buying butter when bread is bought is 2 times is as high as buying only butter. And then comes the antecedent, which is the condition part, the first item, like bread in an association rule. And then come the consequent part, which is the outcome or the item we are predicting, like the thing which is come after then is consequent, and the thing which comes after if is antecedent. Now we'll see how to mine association rules using Python. In Python, finding association rules is easy using the ML extend libraries a priori function. Let's say we are working with a data set called transaction. Step 1 is to prepare the data and then load the data and convert it into a one hot encoded data frame. So first we'll need to import the libraries pandas and ML extend from transaction encoder, and then we have sample data of in transactions bread butter, like we have it in phi array. The first in a bread butter, then bread diaper beer X, milk diaper beer coke, and then we have done the encoder of the transaction and put it in a variable te, and then a array of and applied dot fit method and dot transform method, and we have data frame it. Now simply run the code. So basically we got that the beer is beer bought is false, bread is true, butter true, coke false. So basically it tells how many things have customer bought in one thing. So in this you can see that almost every time, almost not every time, bread and butter has bought in pair. Only the customer one has bought bread and butter together. After that, neither any customer bought bread and butter together. So moving ahead, now we got the step 2 is mine the rules. We use the a priori and association rules command to find the rules. We have extended the ML extend from a priori, and then we have set the minimum support to 0.01% and have created a variable frequent item sets equal to app and use the a priori function and using call names equal to true. And then we have created variable rules and associate the rule. Now simply we'll run the code and okay, so basically we need to check the rules to see the top 10 rules sort by left. So we have sort the rules by value ascending false, print rules dot head, show top 10 rules by left. Now we'll run the code. So we can see the antecedent support for the following table has arrived. We can see the antecedent support for the eggs is zero point 0.2, bread and beer is zero point 0.4, eggs is zero point 0.2, diaper and eggs is zero point 0.2, bread and beer is zero point 0.4, bread beer diaper zero point 0.4, diaper coke zero point 0.4, eggs zero point 0.2, bread coke diaper. So basically it's not worthy because antecedent support over above 40% keeps the data interesting. So now moving forward to confidence difference criteria. The confidence difference criteria checks how different the rule's confidence is compared to the random chance of the consequent. This means we only keep rules where the confidence is very different from random selection. Now, how to apply confidence difference criteria in Python? First, we need to calculate confidence difference, add a new column showing the difference between the rule's confidence and the consequence overall's probability. We have extended the a priori and association rules, imported it, and now calculating average probability of each item being bought. Consequent support equal to df dot mean, and now we have map consequent support to rules the data using using apply function. And then we are calculating confidence difference, which is equal to, and we have taken the mod rules confidence minus rules consequent support, and then confidence difference rules equal to if it is greater than 0.04, then it is necessary for the learning for the machine. And then we have print the confidence difference rules dot head up to 10, showing top 10 rules. So we'll run this code and we can see the confidence difference right here is for every data we got 4%, 40%. So it's we got it on the boundary because the data is interesting when it is above 40%. So we got for the diaper and coke 40%. For everything we got 40%. So it's not that interesting for the machine learning code. Okay, so moving forward to the confidence quotient criteria. The confidence quotient criteria checks the ratio of the rule's confidence to the random chance of the consequent. If this ratio is zero point 0.4 or higher, we consider the rule interesting. So if the confidence quotient criteria is also greater than zero point 0.4, we consider the rule interesting. Now we'll see how to apply the confidence quotient criteria in Python. First, we'll need to calculate the First, we need to calculate the confidence quotient. Add a column showing the confidence quotient for each rule. So we need to add the column. So we have created a column confidence quotient. We are calculating it by dividing the confidence by consequent support. And then filter rules with a confident quotient threshold. And then created a variable confident quotient rules equal to, if it is greater than 40%, we have printed it. So run this code and we can see the confidence quotient for eggs is 1.25, for breads and beer is 2.5, and for everything it is less than 4. Like you can see 1.666, 1.25, 1.666, 2.5, 0.625. So it is not greater than 0.4. So the confidence quotient. So as you can see that the confidence quotient is not greater than the zero point 0.4. So we did not, so the machine did not find this data interesting. Now moving forward to the summary. Association rules help find patterns like which products are bought together. So basically it checks whether the two products are bought together or not. And the confident difference keeps only rules where confidence is very different from random chance. And confident quotient keeps rules with a high confidence to random chance ratio. Oh, okay, guys. So this is all from the video. And in this video, we completed our data science syllabus. So thank you for watching my video.